And again, what is this symbol is not also a character, false. And number, numeric, false. The billion is a character, right? And what is stop? Is underscore stop. Okay, so it's a property of token object that indicates whether a token is a stop word. Okay, it returns a boolean value, true or false. If true, the condition is if the token is a stop word, it's true. If the token is not a stop word, false. So in this sentence, all things are the apple. The word it starts the sentence, right? It's not a stop word. And is it a stop word? And apple is, if you just finish this line, yes, it is a stop word. And looking, so now it continues. Okay, it is looking for some word, relevant word, and it is a continuous sentence, and the root word is look. Okay, now it is not a stop word; it is identifying. At you can just stop. Whatever. This is how the English Code Dictionary is having the hierarchical information with respect to tokens. You may use at for any kind of a stopping sentence, stopping words or stopping characters. That is how we have to understand this. Otherwise, the rest of the information, it is false. Buying is a false, EP is a false, and startup is a false. It is not a stop word. It is trying to stop anything? No. It continues before or after the sentence. But for is one of the stop words for the system. And dollar is not. And numeric one is not. And billion, obviously, you can. So we shouldn't assume that within the sentence, okay, is this a stop word? No. So in common, what are all the informations that can be a stop word? And it has its own hierarchy in terms of this English core dictionary value. So it depends on this information. It is not depending on this sentence per se. Okay, so don't assume that this is this works like this, right? If you see, okay, so this is the one. The stop words are commonly used words in a language that carry little semantic meaning by themselves, but are important for grammatical structure. Example, and is the right. Many NLP tasks, stop words are often removed to focus on more meaningful terms. While carrying out this kind of information, this sentence, it will just remove all these information to consider. So that means while operating or while just going for the contextual purpose, it is always remove the unwanted this kind of a stop words. Never takes it into take it into considerations to make it more the meaningful words or meaningful context. Otherwise, token, if you just consider all the tokens, then it is very really tough process to understand. That is why if you are typing in chat GPT without punctuation, without making any kind of the other meaningful sentences, still it is trying to take your context. That means it removes all the unwanted this kind of a stop words, just removes it, and then it takes and reads only the required information to process your question. Okay, this is how the NLP structure will work. So mostly it will remove grammatical information. Mostly it will remove the unwanted punctuation too, because it also consumes a lot of spaces. Right? So this is one of the. This is a simple sentence. Okay. This is just an example. Okay. So this is what you can just get into this kind of vocabularies. Okay. Let's see what is okay. After tokenization, make predictions of which tag are okay. So we started with the parse, I guess, okay? And then tag. What is tag? Okay, it is very important concept. What are tags? The tags refer to part of speech tags which provide detailed information about the grammatical role of a word in a sentence. They are assigned to each token during the linguistic analysis phase and help understand the syntactic structure of a sentence. So these are the types of POS. Okay. The coarse-grained POS tags, broad categories such as nouns, verbs, adjectives, etc. So this is how it has been mentioned in the dictionary. Noun, verb, adjective, adverbs, adjective, adverb. This all things. The tagging thing is all related with grammatical things. The fine grained. One is coarse grained and one is fine grained. This is like token dot tag underscore. So more detailed tags specific to the language. So these often align with the pen free band POS tag set of English. This is one of the uh, kind of a rule book, right, in English, and they are using this POS in their English core web dictionary. Okay, and then only it will be able to, trying to understand what you are giving, in which language it is taking, whether it is referred to in this set of rules or it is an out of box. Okay, and it is a NN, it is a singular noun. VBC, a third person singular verb, and JJ adjective. If you are seeing this kind of unknown references, it always, it is trying to tag with respect to their own dictionary. That is a part of speech. The English core dictionary having their own set of part of speech. It is not how we are talking or we are typing through colloquial language, right? No. So it just always refers to their context. Then only it will be able to give us the relevant information. Otherwise, it will just mix everything and it won't follow any kind of a hierarchy. That is why, sometimes or some search engines, it is giving you the irrelevant information. The classic example was the Internet Explorer. If you search Internet Explorer, most often it will give the other kind of information. Okay, so which is irrelevant for the information. So this is how it is. Okay, so this is what the tag is. Okay, the other thing, yeah, okay. So this is where the trained pipeline and its statistical models comes in, which enables spaCy to make predictions of which tag or label most likely applies in this context. A trained component includes a binary data that is produced by showing a system enough example for it to make predictions that will generalize across language. For example, a word following the in English is most likely a noun. Okay. So linguistic annotations are available as token attributes. Like many NLP libraries, spaCy encodes all strings to hash values because All the string means all the characters. It just stores in the hash library, hash tables, and then from that table, it is just trying to enable or trying to understand its own context to reduce memory usage and then improve efficiency. If you are not storing your value in this format, right? One is your system will get hanged, or the cloud storage system, which we are just getting the information from the cloud storage like ChatGPT or which they are operating through cloud technology. If it is trying to store in a temporary image as it is like how it is getting stored. Normally, if you are just executing a program, it immediately goes to your RAM. That is a temporary storage or a buffer storage in your memory. I think we already discussed that. Okay. So in this hash values, it is not directly coming into your RAM storage, RAM memory. Before that, it is just having some kind of an alignment. Again, it's again converted to zeros or ones. Obviously, that encoding and decoding is happening. But before coming into your temporary, RAM storage, it is giving, say, for instance, 10 words you are trying to search. Okay. And it is the memory which we are getting into. Because, see, I will show you an example. Yeah. So, what are tags in spaCy? I'm just, asking this. What will happen if, all the things, all the relevant information, just, it will always remove on. Question will be there. The question statements, what, tags, just remove in. So only what, tags, spaCy, these three things are relevant. This rest of the information, which is again stored into hash tables, which is unwanted, are irrelevant to the any kind of when it comes to the storage information. So it won't store anywhere. It just stores in only the hash tables. Hash tables more than efficient, with respect to the temporary storage. Temporary storage, even if you consider cloud technology, even if you come, consider your own laptop or whatever it is, RAM should be there. So in that RAM, only what tag space, only these three things will get stored in those temporary. The other tags, other information, right, which is kind of irrelevant with respect to this. So it just stored in hash table and then just remove. That's it. So it won't record any kind of physical space. That's what it is. That is why we are getting the fast response. Yeah. So that is one of the information we need to so that it reduce memory usage and improve efficiency. So to get the readable string representation of an attribute, we need to add an underscore to its name. Okay, and this is how it looked like. So whatever we have got the the information here, right? Same information, which is kind of a table they have given. Text. What is the lemmatization? The lemma of the text. What is the POS? Part of speech. What is the tagging? Right? What kind of a tag it is? Just now, we read. It is own hierarchy. And then DEP. What is DEP? What is DEP? So DEP refers to the dependency label of a token, which describes the syntactic relationship between the tokens and its head word in a sentence. It provides insights into how words are connected and organized within a sentence grammatical structure. So again, it is a dependency parsing, right? So dependency label. So here, Apple is a dependency label. Yes, it is a noun and it is a subject. Is an auxiliary word. Looking is a root word. It is trying to find out the root word of look. And at is a preposition. It is again one more grammatical component. Buying, right? UK is a compound label. It's a combined word, right? Direct object. Startup is direct meaning. There is no other root or something. And for is again a preposition. It is a dollar is quantity. It's a modulus calculation. It is a numeric calculation. And one is digit and billion. It's again object. Okay. So this is how. So if you see this visualization, Apple is Apple looking directly going and connecting with this word, and this is the verb is not a mandatory task when it comes to NLP, especially when it comes to spaCy, because if this considers, this will very confusing or cumbersome process while taking into the tokenization. So it just removes, because is there any kind of a, it will just immediately find out is there any other relationship between is and looking. If it is a direct relationship, then it removes is and it will just connect with this word. Okay, and from this it is going for the next word and the next word, and this is how it is getting connected, and this is the visualization. Okay, so you can just see all the visualization over here, right? Okay, so this is how part of speech, and also tags and dependencies. Dependency parser, any other thing, it's working. And this is how even Gen AI product is working. So Gen AI text to text, because all these things are coming from the root, from the natural language processing. Okay, right. Now it is a named entities. A named entity is a real world object that is assigned a name. For example, a person, a country, product. Okay. spaCy can recognize various types of named entities in a document by asking the model for a prediction. Because models are statistical and strongly depend on the examples they were trained on. This doesn't always work perfectly and might need some tuning later, depending on your use case. Okay. So named entities constantly getting upgraded, because so many companies, so many named entities, not only companies, even the words. We might think that it might be a constant value. Sometimes the value just they have to upgrade the hierarchical structure, their library information, storage information, right? So it will always getting trained on their own model. If you will not be able to find out something, then it will just refer to the normal hierarchical information, so that your information is just coming in with very generic responses. That is what happened with Google Bard. So whatever you are searching at the time of releasing of the application, it is not trying to connect with the right information. The NLP storage information storage system, it is not getting connected properly, or it is not getting trained properly. That is also one of the reasons. And now it is okay kind of a thing, but still the accuracy when it compares to ChatGPT or any other model, it is low, but still it is strong. It just position itself, just strong large language models. Okay, okay. So I will run this. Let's see. So the Apple, what are we trying to find out in this doc.ents? Uh, so any kind of word you can see. Let's understand in this way. So the entity recognition. Okay, so ER process, they're just giving this name. So don't get any other meaning of it. So in this word, the entity text, entity start character, entity end character, entity label. It starts with zero because how Python starting to read the index value zero. It starts with A and ends with fifth character. The label is obviously the companies, agencies, institutions, organizations. Okay, ORG is a organization. UK, it's a country name from where it is. If we just start from this zero to value, and the UK starting position, the U starting position is 27th place, and it ends with 31st place. And GP is nothing but this geopolitical entity, that is countries, cities, states, and everything. A geopolitical entity. And $1 billion. Okay, $1 billion. It starts with 44th position and it ends with 54th position. It is labeled as money. Okay, the monetary value including the unit. And this is how it is getting stored or getting understood over the back of the system. And this is how you have to make understanding. Okay, so Apple, the organization, is looking at buying the geopolitical entity, right? And then startup for 1 billion, it's a money. So they are just highlighting all these things. Okay, so this is the one thing we need to understand. Okay, the word vectors and symbol. This is another important aspect of natural language processing. The word vectors, we already saw some of the information from, how vectors is working. and how vector is defined right from the SVM models. Okay, so we are classify we are able to classify if it is unsupervised model, if it is an unorganized way getting the database or information. We'll be using this SVM model, support vector machines. Through this vector machines, how it will be able to understand its vectors, right? How it is just based on the vector, how it is getting formed, how it is getting classified or grouped, maybe numeric data or a character, I mean string data, whatever it is. The similar way of vector information, there is a word called word vectors, and also it is trying to find out this similarity. Okay, so similarity is determined by comparing word vectors or word embeddings. Okay, and then the multi-dimensional meaning representations of a word. So even in Tamil, even in Telugu, even in English, for one word should have multiple dimensions and multiple meanings. Because we are following some kind of a dictionary, some kind of an hierarchy, some kind of an organized way of doing or representing the word or grouping the word. Here also the same kind of information is working. Okay. So the word vectors can be generated using an algorithm like word to word WORD to VEC word vector and usually look like this. Okay. So what does it mean? So if you are just saying banana, okay, sometimes it refers to the fruit, right? And the same banana information refers to any kind of other information as well. It is trying to find out all the possibilities through the word vectors. What would be the multi-dimensional meaning of this representation of banana? It is trying to get all the information with respect to the context. Then it is trying to give the responses, whatever you are going to refer in that context or in that the concept. Okay. So this is an important information, and usually you will be working like word to vector. So this is like how you are just it's just an important note how you are representing. So this English core web, it's a large dictionary. LG is a large dictionary. SM is a small dictionary. Just for your information. So pipeline packages that come with the built-in word vectors make them available as a token vector and also the document vector and also span vector. So we'll default to an average of their token vectors. You can also check if a token as a vector is assigned and get the L2 norm, which can be used to normalize the vectors. Here also benchmarking or normalization is happening with respect to the context of your sentences. So see here, dog, cat, banana, some kind of a weird word. Okay. So what does it mean? I think we need to, because we used to, English core web is some small dictionary there. It is, it is a very different thing. Then we need to install it. So it is loading this dictionary, the MD dictionary. What is this MD? This is one type of large, which includes the this English core web large package. It includes 685K unique vectors. That means that much amount of information has got trained in that library in that package. Okay, let's see what is that. How many information it is there. It's a pre-trained spaCy language models, provides a balance between accuracy and size, making it suitable for many NLP processing. MD, the name stands for medium and indicates that this model has medium-sized word vectors for better performance and accuracy compared to smaller models. So SM small, MD is medium, and LG is large. Okay, so you can use whatever. Yeah, this is around 40 to 50 MB size. Components, tokenization, POS, part of speech, dependency parsing, NLP recognition, text, word vectors, pre-trained vectors. Comparatively from small, the medium has more information. This is the larger information. The larger information is containing 685 K, 685,000 unique vectors. Okay. The words dog, cat, and banana are all pretty common in English, so they are part of the pipeline's vocabulary and come with a vector. The word is a weird word, and we just typing it. On the other hand, is a lot less common and out of vocabulary. So its vector representation consists of 300 dimensions of this thing, zero, which means it's practically non-existent. So if your application will benefit from a large vocabulary with more vectors, you should consider using one of the larger pipeline packages. Okay. So what are they trying to say? So dog, it's true. Cat, true. Banana, true. Right? It is not as usual. So what the information says, text has vector. This, dog has its vector. Cat has its own vector. Banana has its own vector. Right? The other usage of this, the non, the unusual word doesn't have any word vector. That means any other representation. This way, it is giving you a false. Okay, and then that is how you have to understand. Is there any other information? It's a normalized vector or OOV. What is this OOV? Copy selection. What is this? So OOV is the out of vocabulary. So the attributes vector norm and is underscore OOV are related to word vectors and word embeddings, which are numerical representations of words used for tasks like semantic similarity, clustering, and more. So whenever you are just seeing the word semantic, okay, let me show you this semantic in space. Yes, we need to break down each and every information which are very new to us. Semantics refers to the study of meaning in language. Okay, this is where it is many Gen AI developers are working on semantic representations. Okay, still there are so many opportunities for uh, semantic search. It is actually research field. So it involves understanding the meaning of words, phrases, sentences, and their relationships within a given context. So you can just um, go and do all the other informations. You can go deep dive. Okay. So this is one of the informations you will be able to see, right? So then let's run this one. So here we are trying to find out the similarity between these two documents. I mean, documents in the sense in doc one variable we have saved I like salty fries and hamburgers. The another information, another variable declared doc2 fast food tastes very good. Okay, the similarity of these two documents we are finding it out using this symbol. Okay, doc2 and similarity of tokens and spans. So what actually it's meant for, and how similar is this one? The salty fries and also the hamburgers, and salty fries and hamburgers and fast food tastes very good. It has its own similarity factors. It's almost 69 or 70% of the information. It is very it has its own similar meanings. So both are it refers to the fast food category. That is what it just says here. What to expect from similarity results? The computing similarity course can be helpful in many situations, but it's also important to maintain realistic expectations about what information it can provide. The words can be related to each other in many ways, so a single similarity score will always be a mix of different signals. And vectors trained on different data can provide very different results. Okay. There is no objective definition of similarity, whether I like burgers and I like pasta. It's a similar depends on your application. So both talk about food preferences, which makes them very similar. But if you are analyzing mentions of food, those sentences are pretty dissimilar because they talk about very different food. Even though it likes, it is they are referring to kind of the food, but it makes two different kinds of food. So how it is getting into this similarity. So that is what the similarity check. Even in Google search engine, if you are trying to search for, I mean, in your brain you are just thinking that I'm just finding out something, but in Google search engine, it follows its own dictionary value. You forget about SEO and other informations. Okay. So this is the first information. It is just trying to get its own dictionary values first, and then only it goes for the context, and then only it goes for other informations, and then it is trying to give out the right